Hello and welcome. Have you ever heard of an element that glows in the dark and could one day power our cities like a tiny star? Today, we're talking about tritium. It's a special, radioactive version of hydrogen, and we're going to explore the fascinating ways it is produced. First, let's understand what tritium is. A normal hydrogen atom has just one proton. Tritium is different. It has one proton and two neutrons, making it heavier and unstable. This instability is why it's radioactive and why it's so useful for things like fusion energy and self-illuminating exit signs. So, how do we get it? There are two main sources, natural and artificial. A very small amount of tritium is produced naturally in the upper atmosphere. Cosmic rays, which are high-energy particles from space, smash into atoms in the air. This collision creates free neutrons. When one of these fast-moving neutrons hits a nitrogen atom, it can knock out a piece and transform the nitrogen into tritium and carbon. However, this natural process creates only a tiny amount, not nearly enough for our needs. That's why we have to make it ourselves, and this is where it gets interesting. The primary way we produce tritium is inside nuclear reactors. There are a couple of methods here. The first method involves using a special material called lithium. Scientists take a specific kind of lithium, known as lithium-6, and place it inside a nuclear reactor. The reactor is a source of many neutrons. When a neutron from the reactor strikes a lithium-6 atom, the lithium atom splits apart, creating one atom of tritium and one atom of helium. This is the most direct way to intentionally manufacture tritium. The second artificial method happens as a byproduct in certain types of nuclear reactors, specifically heavy water reactors like the CANDU design. These reactors use heavy water, where the hydrogen atoms are actually deuterium, which is hydrogen with one neutron. As the reactor operates, some of these deuterium atoms absorb a stray neutron, transforming into tritium. Because tritium is so rare and has a half-life of only about 12.3 years, meaning half of it decays in that time, these production methods are incredibly important for science, medicine, and the future of clean energy. Thank you so much for watching and learning with us today. If you found this topic interesting and want to see more videos that break down complex science, please consider liking this video and subscribing to support the channel. It truly helps us create more content for you. We'll see you in the next one.